Hi students, here I am explaining about polynomials, 10th CBSE. A polynomial p of x is an expression in one variable x. The degree of the polynomial is the highest power of x. Suppose 4x plus 2 is there. What is the degree of this polynomial? Is 1. 2y square minus 3y plus 4. What is the degree of this polynomial? Degree is 2. 5x cubed minus 4x square plus x minus root 2. What is the degree of this polynomial? 3. Now, linear polynomial. What is linear polynomial? A polynomial of degree 1. Examples: 2x minus 3, square root of 3x plus 5, y plus root 2. Next, quadratic polynomial. A polynomial of degree 2. The name comes from quadrate, which means square. General form: ax square plus bx plus c, where a is not equals to 0. Examples: 2x square plus 3x minus 2 by 5, y square minus 2. These are quadratic polynomials. Next, cubic polynomial. What is cubic polynomial? A polynomial of degree 3. General form is ax cubed plus bx square plus cx plus d, where a is not equals to 0. Examples: 2 minus x cubed, x cubed, 3x cubed minus 2x square plus x minus 1. These are cubic polynomials. Next, value and zeros of polynomial. Value of a polynomial. What is value of a polynomial? If p of x is a polynomial and k is a real number, the value you get by replacing x with k is called the value of p of x at x is equals to k. It is written as p of k. Example: let p of x equal to x square minus 3x minus 4. What is the value at x equal to 2? Substitute 2 in the place of x. P of 2 equal to 2 square minus 3 into 2 minus 4, which is minus 6. Next, 0 of a polynomial. A real number k is a 0 of a polynomial p of x if p of k equals to 0. Example, let's check. P of x equal to x square minus 3x minus 4 again. At x equal to minus 1, p of minus 1 equal to minus 1 whole square minus 3 into minus 1 minus 4, which is 0. At x equal to 4, p of 4 equal to 4 square minus 3 into 4 minus 4, that is equals to 16 minus 12 minus 4, which is 0. Since p of minus 1 equals to 0 and p of 4 equals to 0, minus 1 and 4 are the 0 of x square minus 3x minus 4. A 0 is just the value of x that makes the whole polynomial equals to 0. Next, geometrical meaning of zeros. Here we can observe x-axis and y-axis are there. This rough graph. Linear polynomials. The graph of a linear polynomial y equal to ax plus b is a straight line. Key idea: the 0 of the polynomial is the x coordinate of the point where its graph, the 0 of the graph, intersects the x-axis at exactly one point. P of x equal to ax plus b, the 0 is k equal to minus b by a. So the graph crosses the x-axis at the point minus b by a, 0. Next, quadratic polynomials and parabolas. Here you can see the graph, x-axis and y-axis, and y equal to x square minus 3x minus 4. Graph of a quadratic. The graph of y equal to ax square plus bx plus c is a shape called a parabola. The zeros of the polynomial are the x coordinates of the points where the parabola intersects the x-axis. Shape of the parabola. If a is greater than 0, the parabola opens upwards. A is greater than 0. You can see the diagram here. If a is less than 0, the parabola opens downwards. A is less than 0. You can see the picture. How many zeros can a quadratic have? Here 3 cases are there. Case 1, case 2, case 3. Case 1. 2 distinct zeros. Graph cuts x-axis at 2 distinct points. You can see the diagram. And case 2. Exactly 1 0. Means graph touches x-axis at one point, 2 coincident points. Next, case 3. No 0. Graph is completely above or below the x-axis. It doesn't cut. A polynomial of degree 2 has at most 2 zeros. What about cubic polynomials? Cubic polynomial example. Let's look at the graph of y equal to x cubed minus 4x. From the graph we see the curve intersects the x-axis at x equal to minus 2, x equal to 0 and x equal to 2. These are the 3 zeros of the polynomial. A cubic polynomial degree 3 can have at most 3 zeros. In general, a polynomial p of x of degree n has at most n zeros. Here I am explaining one trick. Degree equals to max number of zeros. Relationship of zeros and coefficients. If alpha and beta are the zeros of the quadratic polynomial p of x equal to ax square plus bx plus c, then sum of zeros alpha plus beta equals to minus b by a. That means minus b means minus coefficient of x divided by coefficient of x square. Product of zeros alpha beta, that is equals to c by a, that is equals to constant term by coefficient of x square. Example, putting it to the test. Find the zeros of x square plus 7x plus 10 and verify the relationship. Finding the zeros. X square plus 7x plus 10, that is equals to 7x. You can split into 5x plus 2x. And then take x common out of x square plus 5x. X into x plus 5 plus take 2 common out of 2x plus 10. 2 into x plus 5. Then now x plus 5 take common. So x plus 5 into x plus 2. So the zeros are x equal to minus 2 and x equal to minus 5. Verification. How to verify? Here a equal to 1, b equal to 7 and c equal to 10. Sum of alpha plus beta is minus 2 plus of minus 5, which is minus 7. And formula is minus b by a, that is equals to minus 7 by 1, which is minus 7. So both are equal. Minus 7 equal to minus 7. So sum is verified, sum formula. Then product formula. Product alpha beta equals to, alpha means here minus 2 into minus 5, that is equals to 10, and formula c by a equals to 10 by 1, which is 10. 10 equal to 10. So both are equal. So product formula also verified. Working backwards. Find a quadratic polynomial where the sum of zeros is minus 3 and the product is 2. Here don't forget the general form is k into x square plus 3x plus 2. Often the question just asks for a polynomial, so k equal to 1 is fine. Let the zeros be alpha and beta. We are given alpha plus beta equals to minus 3 and alpha beta equals to 2. We know the general form is x square minus of alpha plus beta into x plus alpha beta. Substituting the values x square minus of minus 3 into x plus 2. This simplifies to x square plus 3x plus 2. The polynomial is not unique. Any polynomial of the form k into x square plus 3x plus 2, where k is a real number, will also have the same zeros. For the simplest answer, we just use k equal to 1. For cubic polynomials, advanced. If alpha, beta and gamma are the zeros of the cubic polynomial ax cubed plus bx square plus cx plus d, then sum of the zeros equals to alpha plus beta plus gamma equal to minus b by a. Sum of products of zeros taken 2 at a time, alpha beta plus beta gamma plus gamma alpha equals to c by a. Product of zeros alpha beta gamma equals to minus d by a. Here not from the examination point of view. Summary, quick revision. Polynomials of degree 1 and 2 and 3 are called linear and quadratic and cubic. Zeros of p of x are the x coordinates where the graph of y equal to p of x intersects the x-axis. A polynomial of degree n has at most n zeros. Quadratic ax square plus bx plus c. Sum formula is alpha plus beta equal to minus b by a. Product formula alpha beta equals to c by a. And cubic polynomial ax cubed plus bx square plus cx plus d. Alpha plus beta plus gamma equals to minus b by a. And alpha beta plus beta gamma plus gamma alpha equals to c by a. And alpha beta gamma equals to minus d by a.